Hello students, today we'll discuss IB Physics Data Booklet, page 6, Equations discussion. Let's start. Subtopic 5.1 Electric fields. Definition of current. Current equals charge divided by time, so charge per second. Next, force between two charges Q1 and Q2 at distance r. K is constant. This is called Coulomb's law. K, expression for K, 1 over 4 pi, and this is permittivity of free space. It is constant. Potential difference between 2 points is work done in moving charge Q between these 2 points. It is work per unit charge. This was definition of potential difference between 2 points. Electric field strength at some point of electric field is force acting on charge divided by value of charge. It is force on unit charge. Then, not definition but equation for current, expressed in density of charge carriers, cross-section area, drift velocity, average translation of velocity of charge carriers, and charge of carriers. Here I have picture for the Coulomb's law. So if you have two charges, Q1 and Q2, for example positive, then equal force will repel them, push them away, and the value is calculated by this formula. Subtopic 5.2 Heating effect of an electric current. Kirchhoff's circuit laws. Sum of potential differences and EMFs equals 0 around any loop. For any junction, sum of currents entering and leaving the junction equals, so how much current enters the junction, so much current leaves the junction. Next is definition of resistance. Resistance of component is voltage across component divided by currents through this component. Then we have 1, 2, 3 equations for electric power. Here no resistance, here no voltage, here no current. If you combine several resistors in series, one after another, then total resistance or combined resistance or effective equals the sum. If you connect them in parallel, that they all have two common ends, then you have such formula of reciprocals. Next is actually definition of resistivity, but mostly this formula is used to find resistance. Resistivity is characteristic of material which with some resistance R, cross-section A, and length L. This is why here I give you formula for resistance of piece of wire through resistivity, length, and cross-section area. Next I give you potential divider. If you have two resistors in series, then voltage in and voltage out are linked by this ratio. So potential divider R1, R2 make potential divider. The greater is R1 relative to R2, the greater voltage it takes out of voltage in. Electrical equations for energy and power. For energy it will be IV time, for power PIV, power current voltage. Also useful is definition of electron volt. Electron volt is energy gained by electron moving through potential difference of 1 volt. So it's 1 electron volt. So charge of electron is 1.6 10 minus 19. This is why we convert electron volt into joule. Conversion of energy in joules to electron volt can be shown this way. So if you divide by charge of electron, you get energy in joule. Electric cells. Electric cells have internal resistance, and EMF equals sum of potential difference on all resistances. So the simplest picture of the circuit looks like this. So we have, this is the cell. Inside we have internal resistance, and this cell provides us with EMF. Outside, what is outside we call load or external resistance, and we can measure voltage across these two terminals. So this is called terminal potential difference. Terminal potential difference is IR or EMF minus IR for open circuit. If circuit is open, resistance is very big, we actually measure EMF. If external resistance is almost zero, it is called short circuit, and short circuit equals EMF over internal resistance. Power dissipated in external resistance can be shown that equals this expression, maximum when external and internal are equal. Subtopic 5.4 Magnetic effects of electric currents. So electric current, so here actually the force on moving charge depends on charge, on velocity, on strength, magnetic field strength of magnetic field, and angle between velocity and magnetic field. Moving charge will have force, and current has force. Definition of magnetic field strength: it is force acting on 1 meter wire with current 1 ampere in this magnetic field. So angles at 90 degrees. Directional force is determined by Fleming's left-hand rule, and when we find the direction of force, if it is charge moving, then second finger is for positive charge the same way, for negative charge opposite way. For current, conventional current, so we put first finger along the magnetic field, second finger along conventional current, and the thumb will be along the force or thrust. All three fingers at 90 degrees to each other. Circular motion. When object moves in a circle, it has angular speed. Definition I'll give you later. The speed and angular speed are linked by a radius. Acceleration and force are called centripetal because they are directed to the center of the circle. By the way, velocity is always along the tangent line. So here we have expressions for acceleration and for velocity, in terms of velocity, and in terms here of radius and period, and here in terms of angular speed and radius. So what is useful? 1 degree is 1/360th around the circle. Radian is the arc, for which arc length equals the radius. Average angular speed is angular displacement, or angle swept divided by time, so angle per second. Period frequency, angular speed, and speed relations are the following. Here we use the idea that circle is 2 pi r, and time of moving around the circle is capital T. Subtopic 6.2, Newton's law of gravitation. So if you have two masses m and m at distance r, then force of attraction, gravitational attraction, will be given by this formula where g is gravitational constant. Force acting on unit mass will be called gravitational field strength. And if you have a planet or star with mass m, then gravitational field strength will be given this way. Kepler studied planets moving around satellites moving around planet, and he found that the greater the distance, the greater the period. But it is not direct proportion, it is square of period and cube of radius. Either this way or this way. We finished physics data booklet equation discussion, page 6.